Tenacious talents of code, it's Prof G, and in our Get Flashy lesson, you learned to flash a circuit playground and use the time library sleep function. And you were presented with two challenges: flash the colors of the Irish flag and create a rainbow of colors and flash them. We'll show you the solutions. We'll also show a better coding practice for easy code modification by using a variable instead of literal values, and we'll demonstrate PyCharm's find replace feature. I'll launch PyCharm, and while it took a while to set up a working PyCharm project, now we can simply reuse this project over and over by modifying our code.py file. You should have made a backup in the prior lesson, but if you didn't do that now, and while I could have left some of the statements up, I'm going to code from scratch to reiterate concepts learned. If you need to review the challenge, here it is. Feel free to pause and read if you'd like. And now let's code. It's always good to start with a comment. I'm going to give it the name of the file, which is irish-flash-py. Remember, comments start with a hashtag. Then we need three libraries, so we'll import them. Import board, neopixel, time, all lowercase. Then let's set up our 10 neopixels on our board and call them pixels. So we'll say pixels, that's the variable name, equals neopixel, lowercase, that's our library up here, dot. We want to refer to the neopixel class inside this library, so we type in capital N neo, capital P pixel. I always press return when this shows up in code completion, because code completion will make sure I've got the correct capitalization and spelling. Then, to use this neopixel class, which is sort of like a blueprint, so that it acts like a factory and will manufacture an object of type neopixel, we add parentheses and pass in any inputs so the factory can make our neopixel object. We're using two inputs here: the location of the neopixels on our board, board dot in all caps neopixel, comma, and then the number of neopixels, which is 10. PyCharm adds the n colon label in front of the number of neopixels that we have. No problem leaving that in there. Then let's create our colors, and since these are going to be constant unchanging colors, I'm going to create them in all caps. Remember, colors are between parentheses, so we'll say green equals between parentheses 0, 255, 0. The middle of the RGB values is green. White equals, and that's all values at full volume, so that's 255, 255, 255. Orange equals, and you might have looked that up, but the official orange color from Adafruit is 255, 40, 0. And then we'll add black, which is really just an absence of light. We'll say 0, 0, 0. Now we were supposed to flash one time, then turn the lights off for 2 seconds, then flash again. So for our first time, we'll say pixels.fill. Remember, pixels is an object of type neopixel, and the neopixel class blueprint includes the function fill. And between the function parens, we'll pass in green, which is the variable we created above. Then we'll say time sleep 2.0 to leave the lights on for 2 seconds. And now I'm going to reuse these two lines of code, just changing the color. So I'm going to copy them. I'll paste them in twice below, changing the second green to white and the third green to orange. Next, I want to turn off all the lights for 2 seconds. So I'm going to paste in those two lines of code again, but I'm going to change the color to black and make sure that you wait 2 seconds after turning it black. Otherwise, you're not going to see the lights off. That sleeping for 2 seconds with the lights off is vital. Then we'll flash a second time, and I'm going to copy these three lines up here, paste them down below, and we've got our two flashes separated by all lights being off for 2 seconds. Nice! So we imported needed libraries, set up our pixels object, created our colors, and handled our flash. Let's open the PyCharm terminal and launch TIO. I can use the shortcut by pressing up arrow. My command to launch TIO and connect to my board shows up. Press return, TIO launches. Oh, here's something worth pointing out. So sometimes the first connection between TIO and the board doesn't show all of the connection output. So for me, you can see that the words above press any key are sort of cut off. This isn't a big deal. I can see that I'm connected, but it's good to be aware in case things look a little bit funny right after you TIO connect. I'll save with a command S. I can see the save as indicator's gone away. Sometimes it takes as long as 5 seconds for your code to run, and my code is running, and it looks spectacular. If you got this right, congratulations. And if not, make your corrections and make sure you understand the areas where you slipped up. And your output should look just like what I'm showing on my circuit playground here. Now notice you've got a full 2 seconds for each color, including black, no lights in between flashes. But now imagine we want to change all of our 2 seconds to a faster flash period, say a quarter of a second. Well, we've hard-coded 2.0 into our sleep function 7 times. We have to change that in 7 places in our code. A better way to code this would have been if we created a single variable with the value of the seconds we wanted to use, and then use that variable name instead of hard-coding the number 2.0 in here. In this way, if we wanted to experiment with values, we could just change the value of the variable instead of having to make 7 changes in our code. Let's do this. We'll create a variable called time_interval, and we'll set that to a quarter of a second. That's 0.25. And by the way, in computing, when we hard code a value instead of using a variable, we say that the value is a literal value. It's good coding practice to avoid using literal values in your code if you think you might change those values in the future. And now I could retype this new variable name over the old 2.0 value 7 times, but PyCharm includes a find and replace mechanism. Let me show you how you can easily find options within PyCharm. On the Mac, you can head up to the Help menu and then enter the option you're looking for. I'll enter Replace, and I see Find greater than symbol Replace as an option. Now, if I use my cursor keys to highlight that value, it shows me the spot where it's located in the menu. But with this option highlighted, I can just press Return, and that will pop up the Find Replace. I see it's above my code editor. I can enter what I want to search for in the search value, 2.0 in this case, and I want to replace this with the variable name time_interval. Now, clicking the Replace button makes just one change at a time. I usually do that once to make sure that the change is working like I intended. And then if I'm satisfied, I can click Replace All. Replace All can be a bit tricky. For example, I wouldn't want to replace all if I had 2.0 in some other location that I didn't want to change to the time_interval value, but this works great here. And PyCharm highlights all the locations impacted by my change, and in the upper right there's an X you can click to get rid of the Find Replace area. So now I can open my terminal, save again. I notice the flashes happen much faster now because I'm only sleeping for a quarter of a second. Nice. And make sure that you save this to your CircuitPython school folder using the name irish_flash.py, and then I can close my Irish Flash tab when I'm done to make sure that I'm working on code.py back on my CircuitPy board. Cool. And here's our roy-g-biv challenge. You can pause and review if you need to. We'll go through this one very quickly since the biggest takeaway here are our color values. So here's a working solution. I'll just show you the code instead of typing it in. Much of the code is the same import statement, same setup of the Circuit Playground's onboard NeoPixels. We use the variable name pixels again. And here are the 7 colors that I've created. 7 values for red, orange, yellow, green, blue, indigo, violet, plus 2 additional values for white and black. You can pause here and modify your code if you'd like to make things consistent with my own. And you can see that I've included a value time_interval that I use in my sleep function to avoid hard coding literals. This is what this code looks like when it runs on a Circuit Playground. We've coded the rainbow. Very nice. Be sure to save this as roy-g-biv.py because you might want to open this file back up if you want to quickly copy the 9 colors you defined here. So hopefully you got the 2 challenges. If not, a good strategy is to challenge yourself again and see if you can solve these problems without looking at the solutions. Remember, with coding, the more you practice, the better you'll get. We also learned about improving our code with variables instead of literals, and we use the PyCharm find replace function. Stay tuned for more CircuitPython goodness and continue to hack.